So yeah, today the goal is really to introduce the Pilot AI Vision Framework. For those who already know about it, it will be more of an in-depth dive and show some cool demos at the end. The title of the slide is really from doorbells to defense. Typically we're at embedded vision, so everyone talks about running on ARM cores, and traditionally that's really where we started, running on Cortex A's, et cetera, moving down to Cortex M's and DSPs. But we also target edge-based applications that are running on full-blown GTX 1080 Ti's. But the problem is still an edge-based problem, right? So these are running in satellites or high-altitude drones where they're still compute constrained. They don't have a high bandwidth connection to the cloud, and so they still have to do everything on the edge. And the problem's a lot harder, so they need more compute. So the challenge is building a framework that scales across all those applications, and that's what we've built. So what is the Pilot AI Vision Framework? So the goal was really to build a deep learning-based computer vision platform to solve real-world problems with limited compute, right? So that's a very generic statement, but we'll go into more detail about the type of applications and what we mean by that. High level, how do we do that and how do we target that? At the very core, we just build better neural network architectures, and in particular, architectures that run very efficiently on modern memory architectures, in particular commodity modern memory architectures. Second, we also optimize core compute kernels across a variety of target platforms, everything from low-level DSPs to Cortex M, Cortex A, GPUs, et cetera. We wrap this all up to be very easily usable by our customers in a vision toolkit that exposes common vision functionality like detection, classification, and tracking. And then it's a like 3-function call API that is plug and play and drop in that customers can use to retrofit existing platforms or deploy new cameras.